All right, let's take a look at 22. It wants us to graph 6 lines with these gradients. So there's the slopes are given to us. Gradient, slope, same thing. And then give the equation of each line. So, we're all going to have slightly different graphs just because we're all going to have different y-intercepts. Let me use my thing for this. Okay, so I'm just going to put this here. Let's see. Make that a little bit bigger and go with the darker color. Okay, so let's put that up here. So I'm just making my graph now, and I'll go from there. So I'm gonna graph all these different lines. Let me just pick a y-intercept first that I want to be my y-intercept. It doesn't really matter where it is. I'm gonna make it +2. Okay, so let's go ahead and graph some. So, I'm just gonna look at the zero slope first. Zero slope, it doesn't go up at all. It's just gonna stay flat. So if I do that, I can, let's say, I can just keep pasting more of these in here. So I'm going to put this in here. Let's see. That would go right here. And I'm just going to change that to blue. Okay. So I got a blue one there. That is my zero slope, okay? What is the equation of that line? So if I look at that, that's just y is always equal to 2. I could say y equals 0. Y equals 0x plus 2. Well, what's 0x? It's 0. So just y equals 2. And if you think about that line, y is always 2 forever, right? We have many different x values, but that really does define that line as y equals 2. Okay? My next line, so I'm going to, again, I'm going to insert a line. It's going to start this y-intercept here. Let's go with a red color. Or maybe I'll start here. Let's go with a -1. So -1 would be down 1 over 1, down 1 over 1 like this, okay? So it's kind of like a 45 degree going through here. I can stretch that up here too. There we go. That would be -1. I'll make that one red. Okay, let me just change that to a little bit thicker. There. I'm just gonna keep copying that. That one there. We have that y-intercept every single time. So this one is y equals -1x, right? I can just say -x though, plus 2. Y-intercept should be the same. This is always the same y-intercept, okay? And then, what I want you folks to do is to continue with this, and you're going to graph the next line that has a slope of +2 and then -6, a quarter, -1/4, and so on. Okay. All right, so I caught up with all that graphing. I got my graphs here. Let's answer the question. So what do you notice about the relationship between the slope and what the graph looks like? Obviously the slope changes the angle that we're at. If we have a positive slope, so positive slopes would go up as we go left to right. Negative slopes are going down, okay? As the coefficient or the slope gets to a larger number, it's steeper. Whereas when we see fractions, they get closer to 0. And when we get to 0, 0 is flat. There's no slope at all there. What do you notice about the y-intercepts? Well, it's kind of obvious. They all have the same. So they're all the same y-intercept. This is a weird question here. Consider graphing a line that is undefined. Okay, so an undefined line, that's vertical, right? That had the same y-intercept. What would that look like? Okay, well, let me just find a different color here. I'm running out of colors, really. Who knows? Okay. I think I ran out of colors. Anyway, let's not even draw a line, but that would go through here. We could, if we went through the same y-intercept, it would actually be the y-axis, right? And if you think about that, is the y-axis an intercept? I mean, where is it intersecting? It's intersecting everywhere. So it would be a vertical line that goes through that same y-intercept. It is the y-axis. That's what it would be. All right, so just kind of a question to make you think about slope and y-intercept. Visually, what are the characteristics and so on.